Hi, geometers. We're back in our rigid transformations books. We have already talked about translations and reflections, and today we're going to dive a little deeper into rotations. So if you can find the rotations page, it's the last page in your book, flip here, and we'll begin. So a rotation is a turn. So you can just write here, turn. It's a turn. And it's a transformation around a point, which is the center of rotation. So we can turn something lots of different ways, but we need to know what we're turning it around, what we're spinning it around. And so where we're spinning it is called the center of rotation. And rotations can be clockwise or counterclockwise. So just to make sure we're all comfortable with that, clockwise is the way that the hands on a clock go, so turning around that way. And we'll abbreviate that CW, clockwise. And then counterclockwise is, of course, the other way, turning that way, and we'll abbreviate that CCW for counterclockwise. So doing a rotation is really difficult. It's hard. With a reflection, you sort of move to the line of reflection, and then you move to the other side the same amount. With a rotation, there's no solid rule like that. So we can do rotations using tracing paper or something like that, but the only way we're going to be able to do it using coordinate notation is when the center of rotation is the origin. And the origin, as a reminder, is the point 0, 0 on the graph. So all the rotations we'll be doing in this class will be centered around the origin, and so there are some shortcuts that we can use. So let's talk about them. So these shortcuts are purely for rotations around the origin. So first we have a 90-degree rotation counterclockwise, and I'm going to just draw that arrow again. It's so tiny. I want to make sure you know we're turning that way. So 90-degree counterclockwise rotation, xy will transform to negative y x. And I think just like we did with the reflections, it'd be a good idea if we could write out what this means. So the first thing I hope you notice is that the x and the y are swapping places. So let's write that. X and y swap. But then in addition to the x and the y swapping places, the y value in your original point becomes opposite in our new point. So I'm just going to write opposite the original y. So that's what that rule means. And then the other thing we need to do before we move on is that sometimes you'll rotate counterclockwise. In fact, most of the time in geometry we do. But sometimes we also will rotate clockwise. And so what I want you to think about is if we were to rotate clockwise a certain number of degrees, it would be the same, right? So rotating 90 degrees counterclockwise is the same thing as rotating clockwise a certain number of degrees. And I'm hoping you can figure out that it would be 90 times 3. 90, 90 more, 90 more. So that's 270 degrees clockwise. So this same rule will work for a 270-degree clockwise rotation because that's the same thing as 90 degrees counterclockwise. Okay, 180-degree rotation. The rule here is really simple. Opposite x, opposite y. So to spell this out in words, we're not swapping anything. We're just taking x and y and making them both opposite. So opposite of both x and y. And a 100-degree rotation, you'll notice that here it doesn't say which direction. And the reason is because it's the same either way, right? So 180 degrees clockwise puts you in exactly the same spot as, oops, I did that wrong, counterclockwise. All right. Last one, 270-degree rotation counterclockwise. So that's when you go 90 degrees and then 90 more degrees and then 90 more degrees counterclockwise. So that's 270 degrees counterclockwise. And the rule for that rotation is y negative x. So it's very similar to this rule where the two swap positions, but this time instead of making the original y opposite, we're going to make the original x opposite. So let's write that out. X and y swap, and then you do the opposite of the original x. And then I hope you can see here that a 270 degree rotation counterclockwise is the same as a 90 degree rotation clockwise. All right, so those are the rules. You do not have to memorize these rules. I'm putting a red dot on my starting point here just to make it clear. I'll put one on the end point too. Make it pretty. You'll always have a formula sheet. So these rules will be provided for you. You don't need to memorize them, but you do know how to use them. So we have two examples that we'll go through, and I don't think it'll take us too long. Here we go. Example 1. Graph the figure, then rotate 90 degrees counterclockwise. So the first thing we probably should do is plot the pre-image points. So what I'd like you to do, I'm going to do it up here without talking through it. I'd like you to do it on your own and then check up here when you're done. Okay, if you're not done, pause it. If you are done, go ahead and look up here. This is funky, so let's talk about it. There's no A, B, C, D or anything like that, so I don't need to worry about plotting the letters with my points. But whenever we're doing transformations, you should assume that we're transforming like a figure, a polygon. So I'm going to take my last point back to my first point. And when you have a lot of points like this, it's a really good idea to connect them as you go. Otherwise, it can be hard to see what the shape is. So I connected them as I went so that I wasn't confused about what point to connect with what other point. And then I'll connect my first and my last points back together. So that's strange looking. Let's go ahead and do the rotation. So first step, that's what we're trying to do. We need to go grab the rule and write it down here. So 90 degree counterclockwise. Let's look back at our rules. Okay, 90 degree counterclockwise is this first rule. 90 degree rotation counterclockwise. This is the rule. XY goes to negative YX. Write that rule down under example 1. So back over here. XY is being transformed using the rule negative YX. Once you have the rule, the rest of this is pretty simple. So I'm going to start by setting up my points, and this is really important. I will take points off if you don't have the parentheses, because if you don't have the parentheses, it's not a point. You really need them, and you need the comma too. So first thing I'm going to do is swap them. So they're going to switch places. Negative 1 is going to go over here, and the 3 comes forward. And I'm just going to go through all of them like that and just swap them. So I haven't done this part yet, that negative part. All I've done is swap the positions. Now I'm going to go through and make sure that this y that came forward is opposite of what it was originally. So the 3 is going to become negative, 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 and that negative 1 will become positive. So I'm just going through after I've flipped them and doing the opposite thing. Some of you might find it easier to do it as you go. I find it easier to just do it all afterwards. And then just be aware that last little guy needs the positive because it was negative originally. Okay, let's plot them and see what happened. You can do this, I'm going to do it again without talking through it, but as you plot these, connect them with lines as you go, and then don't forget to connect the last point back to your first point. So when you're ready, go ahead and look up, and hopefully it looks something like this. And then before you move on, a rotation is a rigid transformation. So you want to make sure like this that this looks like the same shape and size, which to me it does, but it's a little hard to tell because it's so funky. So I have a trick that I'm going to show you that you're not going to be able to do, but I want you to just watch. I have this transparency film. It's just like overhead projector film, and it's clear. So what I'm going to do is test this out to see if I did it right. So I'm going to put, the X and Y axis down, and then I'm going to just, as carefully as I can, trace my pre-image. Okay, there we go. And then I'm going to, you can see it's just traced. I'm going to take this and rotate it 90 degrees around the origin. So I also have this paper clip, and I'm going to unfold it so that I can use it as a poking device. And I'm rotating around the origin. So my center of rotation is right there, right at the origin. I don't know if you can see, but right at the origin. So I'm going to poke it there so that it doesn't move, and I'm going to turn this 90 degrees counterclockwise and see if it fits on top of my green shape perfectly, because it should. 90 degrees is would bring this axis to this axis, so a quarter of a turn. So here we go, 90 degrees, bam, perfect. Okay, so that's how we know that the rotation is correct. And it's not fair because you probably don't have transparency film, but I'll be able to give you some in class if you want it. Let's look at example 2. Rotate the figure 180 degrees, use coordinate notation. So let's go ahead and grab the rule for a rotation of 180 degrees, looking over here. XY goes to negative X, negative Y. So let's write our rule down. And we're going to start by writing down the points. So point S is 4, 4. And that's going to transform to S prime. Don't forget to put the prime. At this point, I'm going to ask you to pause the video and complete this example, totally complete it, and then check back in with me to see if you got it right. So 1, 2, 3, pause. And we're back. So check and make sure that your work looks just like mine. This looks like a rigid transformation because it's the same shape and size. Let's go ahead and label that this is the pre-image. And then our new figure is the image. It's not necessary to write that down every time you do a problem, but this is really confusing, so I think the more we talk about it, the better. And then I'm just going to check it using my fancy transparency again, just so I can prove to you that this is a rotation of 180 degrees. So there's my pre-image, and here's my fancy paper clip, and we're rotating around the origin, so I'll poke it in, and I'm going to turn 180 degrees, so that's 90 plus 90 more. And it doesn't say which direction, that's because it shouldn't matter. So 90 degrees, boom, and I'm going to do 90 more degrees. Boom, and it fits perfectly. Okay, so there's the rotation, and then you can see all the way in between, right? That would be 90, 180, and then 270 would look something like that. Makes like a pretty pinwheel. Okay, anyway, that's it for rotations. We're done.